everybody. My name is Martin Peřina and I work at Red Hat on oVirt and the Rev project. Today we will be talking about oVirt extension API. We will notice some already existing implementations of the API, and we will talk about future plans, what we will hopefully do with those. So just a brief introduction. In oVirt is centralized management systems for virtualization. We have three main parts. It's the engine, which is the brain of whole solution. We have a lot of hosts on which is running VDSM, and on those hosts we are executing our virtual machines, and we also have the storage which is shared across these hosts. Prior to version 3.4, the extensibility of oVirt was pretty limited because we have only two types how to extend oVirt without going to into the project and push the code. So we have engine UI plugins which were possible to inject custom plugins into oVirt management UI, and those plugins were able to communicate with engine using REST API. And on the host we have VDSM hooks, which was, let's say, some custom scripts or programs which could be executed at a certain predefined event. So the extensibility was pretty limited, and the whole project was pretty monolithic. Just a brief, what is the magic AAA? So it's authentication, which just verify that the user tries to log into system is really the one who he claims to do. Authorization, just verification of the resources that users can access. And accounting, it's the statistics about all of those stuff. So when we planned the oVirt 3.5, we know that our AAA implementation was pretty monolithic. It wasn't good. It was very complex using Kerberos and LDAP. It didn't support all the LDAP hosts we need. And it was kind of know that we really need to rewrite this. And when we decide how to do it, we kind of have a discussion if it should do the same way as it does, so it directly injected into agent as another monolithic part, or we could do this using some kind of extension API. So in the future we could use this extension to split the monolithic engine into several communicating parts. So we choose this extension-based because it's much more, extensible or easier to create just a new extension using stable API. We also wanted to be able to use some other languages which can be injected into JVM, such as Python or JavaScript. And also we wanted this API to be exportable to whole parts of engine. So in future we hope that the same extension API will be used on VDSM and also on the UI side to have just one single piece of extension API. So oVirt extension API was introduced in oVirt 3.5. At the moment, when we have stable 3.5 and 3.6 version at the door, it's used for AAA and for logging, but it's possible to create a new code using this API for pretty much everything. We are currently using JBoss Modules to load those extensions, and the extension is configured using text property files. When we decide how the extension API should look like, we decided it should be as simple as possible. So the whole extension has just invoke method with map of input parameters and map of output parameters, and that's it. Each map has its keys. These keys are simple classes which contain just the name of the key, UUID to be able to identify exactly what this is, and also a class which get us the type of the value. Engine extension API, it contains some, let's say, basic types. So extension UUID is a class that contains UUID and the descriptive name of it. This is injected into X key, which contains of this XUID and the type of the value that this key is used for. And the whole extension XMap is, let's say, the map which enforces a runtime type checking for the value based on the type that is presented in the key. Everything that is needed for extensions is contained in a base class, which contains common constants for all the extensions. So there are invoke keys, which can be used for keys in the invoke methods. There are basic invoke commands. So if in the just plain extensions, we have only 3 commands: load, which is used to loading the configuration and the classes of the extension; initialize, which is called next to initialize everything that extensions need; and terminate, which is called when the engine goes down or when you ask to terminate your extension. And there is also invoke result, which is some kind of special key, because every invoke method can have just 3 types of result: either success or unsupported if this type of command is not supported by extension, or failed. And in this case, you can get in the output mat the reason why the operation fails. As I said before, the extension is or contains 2 parts. The first part is a jar file, which is placed into JBoss module structure, and this is just put into engine's JBoss modules class path. And the configuration file, which contains everything that is needed for the extension to be loaded into engine and used. This configuration file should be placed under etc oVirt engine extension D, and this is the directory that is scanned and loaded for new extensions. How this configuration file looks like, it's pretty simple. We have a name here, which identifies the name of the extension. We have a loading method. At the moment, it's only JBoss module, but there might be more in the future. We have the name of the module in the JBoss module structure. We have the class that this extension is implemented in, and we have the API that this extension provides. At this simple example, it's just the extension, so just the basic one with 3 commands that I showed before. So how does the startup process is going on? So when engine is started up, one of the first command is the call to the engine extensions manager to initialize the extension. So he just scans all the configuration directory, sorts this configuration file that he found, and for each configuration file, he tries to load the extension using load command. If something bad happens, he just throws an error that this extension cannot be loaded. After that, for all successfully loaded extension, he called initialize command, and also when something bad happens, he gets an error that this extension cannot be initialized. Once this is done, we have a list of successfully initialized extensions which can be used later. To get access into the successfully initialized extension in Engine, we have extension manager class, which is somehow API for the engine to get the extensions and work with them. So we have four, I would say, methods or important methods. It's get extension by service, which you can say, for example, I want all extensions that supports AA or logger or auth-n. You can also get a specific extension by its name. You can get all loaded and initialized extensions or all extensions that we are able to find out. When we get into the extension implementation, it's set in the documentation that extension, when the command is invoked, should not fire any exception at all. Everything should be handled inside the extension and put properly into the output map. But we want to ensure that this is true, so each loaded extension is somehow covered with extension proxy, which makes this real for engine. So every time you execute invoke on the extension, it's invoked under this extension proxy class, and this handles possible exception that can happen during this invoke command. So this is it. It's pretty simple. Do you have some questions so far? Okay, so if not, I will go on and I will show you what extensions currently we have and what things we can do with them. The first extension that was implemented was the extension API for logging. It's pretty simple. It's used mainly, to get the logs produced by engine to be able to forward them to some kind of external logging infrastructure. At the moment, it's used mainly to get engine logs into syslog daemon in some other server. So everything that is needed to create some more extensions for this logger API is stored in this logger class. Currently, in this logger API, we support 3 commands. So the publish the log record, flush the log records if it's needed, and close this logger extension. At the moment, we have one implementation of this logger API. It's log4j, and it just publishes the engine logging records using log4j, and that allows us to use all log4j appenders that is available to pass this logging records from oVirt engine. And as I said, this is primarily used to get logging records from engine to the syslog daemon. I will try to show you some sample code now. So if we take a look at what is the extension, it's pretty simple interface. Just as I said, just one invoke method, input map, output map, nothing more. So this is the only thing that your extension needs to implement. If we take a look at this logger extension API, so we know that we have the key log record, which is the key which will contain the logging record. It's the instance of Java util logging log record class, so we don't do anything special here. And we have 3 commands that are implemented in this logging API. So publish log record, close the logging extension, or flush the records. If we take a look at actual implementation, so this is the log4j implementation, just implements the extension. Let's take a look at the invoke method. So we just get from the input type of command, if it's load, execute load, init, or publish. Currently for log4j, we don't need to implement flush or close method because it's done automatically in log4j. So if we take a look, for example, in load, the only thing that is needed, we just get the informations that is contained in property files, which is already loaded into our config class, and we just put it into this output math. So extension manager will know what is this extension, what's its version, license, and so on, to be able to identify it. Now if we, so init, it's just not that interesting. If we take a look into the publish, it's pretty simple. We just take the log record, create new logging event in log4j for this. We have to somehow map the log level from Java util logging API to log4j API, and we put the message and exception if accepted, and flush this everything to log4j, which is already configured with its appenders. So this is, I would say, pretty simple. Any question about the code?
Can you have multiple of the same basically, yes, we just want another extension.
Yeah, you can, at any moment there can be any multiple invocations of this logging command. There are no logs or something.
How do you manage a lot of extensions?
Sorry?
How do you manage a lot of extensions? Also, modules, do you have any kind of management?
At the moment, no. It's just take the log4j XML file that is configured at the extension, and you just push everything according to this log4j XML file. So there is no UI how to configure it. That's on your own.
Why did you choose the extension map and not the standard API?
Well, I could show you the standard API, but there is no implementation. So there is no implementation of extension. The bare extension. So this is the simplest extension implementation we have. I can show you the AA, but it's far more complex.
It enables you to compile out of tree, like doing separately modules.
Yeah. Currently, the extension API is part of oVirt engine. Source code, we hope that for next version we will split it into separate packages, so if you try to introduce new API, you won't be needed to get it into engine code. We will just create a new API specification and put it into your own package, and using just this package, you can create your own extension implementation.
Question here. I understand that the extensions are JBoss Modules, but how difficult would it be actually to have extension running in a JVM outside of the engine? So, for example, if we would like to actually pull a bit of functionality outside of the engine and running somewhere else, how difficult would it be actually with current code base to do it?
Well, currently we don't have any communication part to have engine running on one JVM and the extension on the other one. So I can imagine at the simplest that you could introduce some communication extension, which would just passes the commands from one JVM to the another, and on this another JVM you will just have implementation of or execute implementation of extension manager, which will manage the extension on the second JVM. So this can be done, but at the moment we just suspect that all the extensions run on the same JVM as engine. But I don't see there really big issues to expand this using just some kind of communication extension. So if there are no other questions, I will continue with the presentation, and we will take a look at the AAA extension API. As I said before, the AAA consists of authentication, authorization, and accounting. For each of these parts, we have a special API. So for authentications, we have authn, which is used to verify the user that's trying to access the system. At the moment, we support either username password verification, or we support negotiation. The output of this extension is authentication record, which contains the principal of this verified user, and it also contains some kind of time interval which tells the engine after how long this interval is passed and the records are no longer valid. Another part of this API is authorization. We call it auth. It's used to provide details about the user. So at the moment, you can get, using this API, user information such as first name, last name, email, whatever that is configured. You can get all the groups and even nested groups that user is part of. And so, as I said, the input is this principal record. The output is this authentication record with all additional records. The third part is accounting, aka ACCT. At the moment, we get some basic informations about successful, unsuccessful login, login time, logout time, and so on. In future, we will hope to extend this to the fully auditing capabilities of this. So at the moment, it's, I would say, at the basic level that we currently have. Another part of this AA API is called mapping. It's used for very special, username or login name information, to transforming them for the format that we need. For example, if you log in with the Windows style, like domain, under domain, the username, it will separate the domain name and the username, so we can use it just for logging the username as we need. We also using it from removing the Kerberos suffix and so on. It's pretty configurable. Not much to say. And the last part of the AAA is filters. It's let's say it's not really part of the API, but it's part of the engine which somehow is needed for the AAA API to work. So at the basic, it consists of the filters which process, the input result, either get from UI, web admin or user portal, or from REST API, and tries to get this request authenticated, authorized, and so on. So it's there. Currently, at the moment, as I said, we support basic authentications, we support Kerberos negotiations, and we use those filters also for session management. So all of this is part of API. And at the moment, we have several implementations of these API. The first one is internal. It was part of the engine before, the AAA extension transformation. We just get this internal to be proper extension so we can use it. The only thing that it provides just one user with configurable password and nothing more. So it's pretty simple, but that's what we need, at least for the very minimal installation of engine. So after installation, we have at least one user that is able to log into engine and do something more. The second extension we have, and now we call it legacy, it's Kerberos ADAP. It's the whole code that I talk about was in 3.4 and earlier that we want to get rid of, but we need to support upgrades. So we somehow covered this old API into proper extension. And currently at the next or the incoming version 3.6, it's deprecated, and all users that are currently still using it should migrate to the new AA LDAP, which I'll be talking next. So these two were old, now the new extensions. For 3.5, we introduced a AAA LDAP extension. It's a complete rewrite of extension to provide us users and groups from LDAP server. It doesn't use Kerberos, finally. It just used plain LDAP. It's fully configurable using simple text property files. So if we want support some kind of new LDAP server or some very special customer-based structure of the records in the LDAP server, everything can be configured using just text file, no more coding. It also is very optimized. It supports us some things like SSL or TLS authentication. We can have pool of connection to LDAP server and more and more. So every users that used LDAP in oVirt before is advised to migrate its configuration into AA LDAP. The other extension is what we have is AA Mists. It's kind of, I would say, utilities extension that allow us especially to use Kerberos authentications for our users, because when oVirt is deployed behind the Apache server can be configured using mod-auth kerb, and when the user is authenticated to Apache using Kerberos, this module just pass this negotiation information into AA Mists, and we are able to get this authenticated user, and no need to prompt for username or whatever. And the last implementation is JDBC. It's introduced in the upcoming version 3.6, and it's just do the same thing as LDAP, just the users and groups are stored in a relational database. In this new 3.6 version, we will install this extension as default. So we will have, when you install oVirt 3.6, you will have installed JDBC, so you no longer need any LDAP or external server. If you wish, all your users can be defined in the same database as oVirt, and you can manage those users using command line tool with all capabilities that it needs. So you can create user, you can edit user, change the password, you can create, edit groups, add groups into other groups using nesting, add groups to users, provides every information about those features that we need. So these are current existing extensions. Do you have any questions about them?
Yeah. How does extension is being authenticated by the engine? Anybody can put an extension in. It works.
Yeah, because when you want to upload the extension to the engine, you need access to the to the server, and you need to have the rights to restart engine service or upload the files at proper places. So when you are able to do this, you can inject any extensions you want. There is, I don't see any good in have some kind of other authentications that, okay, this is the extension and it can be used only for some specific task. No more questions? Okay, so the last part is engine extension tools. At the moment, we have the tool that enables us, to or in 3.5 version, the only thing how can you find out what extensions are installed, what they provide, where they are located. You just get to the proper directories, take a look at these configuration files, edit them, and find out what's in them. In 3.6, we introduced this oVirt extension tool, which has the ability to list extensions, show their configuration, show what's their implementation, where are the files placed, and it also has very important things for developers. You can test your API, or you can call API or the extensions outside the running engine. So for example, you have a running instance of the engine and you want to add another AAA provider, for example, for a new LDAP server. And so you configure it, but you are not sure if everything works. And you don't want to restart the engine, so it will be visible to your user before you actually validate that it works. So using this tool, you can just put the property files to proper places, execute this tool, and for example, you can test if your user is able to authenticate. You can test what groups are in this user. So whole API that is provided by the extension can be tested in this tool. For example, for login extension, you can test if your login info is really gets through to the final destination that you want to do this. So this is the tool. Any questions about the tool? If not, let's take a look at future plans. For the future, we would like to create an extension which will connect over to SSSD implementation. At the moment, we are not able to do this because current SSD implementation lacks a few things that we need to be able to support it. But once SSSD developers finishes their implementation, we will be glad to have this extension. What is really planned and what is, I would say, almost finished is single sign-on service for oVirt. We want to get this into 3.6. Unfortunately, we didn't make it, so it's planned to be in the next release. And it will allow us to do the proper single sign-on for all parts of oVirt infrastructure. So you can use single sign-on for logging to user portal, to logging to web admin portal, logging to REST API, and also accessing the reports and DWH API using this single sign-on. And at the moment, oVirt 3.6 is coming in very few weeks, and we are currently discussing what other parts of API we could expose or what other extensions we could create. So, not sure, but hopefully in, let's say, a few years, the monolithic engine will be split into many extension parts which will communicate using API, and it would be much easier for new developers to get in and start it to cooperate with us. Any questions? If not, thanks for your time.